What we are going to look at next is the support of transactions inside the database engine, exposed to or being exposed to you as a developer in the code. I have already mentioned that every time you send a SQL statement to a database engine, a transaction is created for it, and it's placed inside this transaction, and it runs inside the transaction in its own thread. But what I would also like to tell you is that you have control exposed to you from the database engine that enables you to specify how would you like to run a specific SQL statement. So most database engines enable you to write stored procedures, or basically functions made up of SQL statements. And when you're doing that, you actually have control on specifying a set of statements to be executed as a single transaction. So all your exposure up to now to SQL, if you recall from your database 1 experience, you would write a SQL statement and send it to the database engine to be executed. In fact, what you could also do is you can group a number of SQL statements, a sequence of SQL statements that you would like to execute, and you would put them explicitly in a transaction by encapsulating them inside a begin and commit keywords. Then you pass the whole thing to the database engine to be executed as a single transaction, which means two things. The first one is that all these statements are running inside the body of a single transaction, so it's running in one thread. And this transaction, because of the notion that we talked about before, that a transaction moves a database engine from a consistent state to a new consistent state, this transaction as a whole, with all the SQL statements that you have put inside it, will run atomically, which means either all of these statements will run correctly without producing any error from beginning to end, or if an error happens, let's say for example you're doing a computation and you divide it by 0, which resulted in an error thrown by the database engine, then none of the effects of the statements prior to the error will be persistent in the database engine, which means it's as if it never ran. Now, this is a very nice feature because sometimes you are actually going to do a set of related modifications to the database engine, and if one of those modifications or computations fail, then you want to basically cancel the whole task that you were doing. Let's say, for example, you're building an e-commerce website and people are going to buy stuff from you online. Now, the kind of changes you would be making when someone buys an item from your website is the following. You would like to decrease the stock of this item by 1. You would like to put a shipping order for this item, so that will be probably another table that documents that you have these outstanding shipping orders. You would like to charge the credit card or create an invoice for the user who bought this specific item. You would like to record any changes in the address if he has changed his shipping address from his billing address. So there will be a number of tables that you're actually going to modify or update. Now, if any one of those pieces of the transaction or statements or updates of the transaction fails, you shouldn't go ahead with actually completing the transaction the business transaction. For example, if you try to charge his credit card and then the credit card company sends you a message while you're trying to charge his credit card saying that he's out of credit. So if you have already in your logic changed the number of items, decreased them by 1, you are going to go back. If you had like 100 TVs and he was buying a TV as an example, you just made them 99 by taking 1 out because you were going to ship him this TV. Now when you discover that he has no credit card balance available, so you're going to go back and increment the one that you just subtracted. While there is actually another way. If you just cancel the transaction in the middle using a statement that is part of the SQL syntax that you know for the specific engine that you're building for, then everything you've done before this line where you find actually that he has no credit will be just canceled. Why? Because again, a transaction is an atomic or executes atomically, which means either it gets executed or it doesn't get executed, everything inside the transaction. And in all programming, interfaces for popular database engines like PostgreSQL, that's what you see here in this slide, or Oracle or SQL Server, there is this ability for you actually to group a set of SQL statements and put them as one unit to run atomically, which means either all of them run or they don't run at all, and you just pass the whole thing, the whole structure or code to the database engine, and now the database engine understands that it's going to, instead of creating, say you have 3 SQL statements inside your begin and commit piece of code. If you have 3 SQL statements, it's not going to extract them from the begin and commit from inside there and then create 3 separate transactions. It's going to create one transaction and put all of them inside this transaction. Now, I have here another example in the following slide. For SQL Server, the way you do this is you write begin transaction and you put any number of SQL statements. Each one of them will end up with a semicolon, and then the next one, third one, fourth one, and so on, and finally you say commit. Now, where do you actually write this? There's a number of ways you can do it. You could log in to the shell of the database engine, and you start typing these statements: begin transaction, update account, whatever, insert into, whatever, select from, insert into, whatever, and then you say commit, semicolon, and then you press enter, and this is how you submit a transaction. But obviously this is a very manual process. Now, another way you can actually do it is you can put this whole transaction that we were describing in what's called the stored procedure, which is actually, think of it as a function or a method in Java, but it's specific for database engines. And then you put it in a text file, and you upload the text file to the database engine, and when you would like to run this specific transaction, you just call the stored procedure name. So in PostgreSQL, it would be something like create procedure, let's say foo. And then from your Java code or Python code or PHP, you just call, call foo, and that executes the stored procedure inside the database engine, and consequently executes the transaction that's placed inside the stored procedure. Now, there is a third way, which is more common. If you have seen this before, most likely that's what you have got exposed to, which is that there is actually, in the Java language, as an example, there is an API, there is a set of methods you can actually use to create a transaction and insert into the transaction a number of SQL statements and then send them to the database engine to be executed. So this is part of what's called the JDBC package in Java. There are methods that enable you to actually do that. Now, the SQL commit that we were just seeing in the previous 2 slides actually is the same commit we discussed when we were talking about transactions in a number of places, including, for example, in the undo redo logs, okay, and in other places when it comes to implementation of transactions, okay. Now, commit means what it says, what we have discussed before. It means commit the changes from memory to disk. So if you reach a commit, then you are safe. If during the transaction you're in a safe, I mean by you are safe, it means you are now guaranteed that your changes went to the disk. Before the commit, all the changes are being made in memory, but a commit is basically saying to the database engine, you really gotta go and save this to disk. So this is something that we have discussed before. It involves the buffer manager, it involves the log manager, it involves also somehow the transaction manager. So, but commit is an important kind of step in the process of writing transactions, because that basically means you are asking send it to disk. It's not going to be sent to disk right away, depends on the implementation of the database engine, but it's a signal to the database engine that it needs to consider that and should do it as fast as possible. Now I'm going to show you here an example that we are going to use through the rest of these slides that shows what can you do with transactions and what are the parameters that you can control. Now I'm talking here about a table that documents which bakery is selling which bread for what price. So I have a single table that's running in my example. Okay, let's assume there's this guy called Joe who is selling two types of bread, baladi for $2.50 and shami for $3. Now another user, or there is a user by the name of Sally, is querying this table to know the highest and lowest type of bread in terms of price that Joe makes. So currently he has in the table two entries or two rows, baladi and shami. Now let's say while actually she is writing her query, Joe logs into the database and he decides to update his information because he has stopped selling baladi and shami and he's only selling French now for $3.50. So what that means is we have two transactions being sent to the database engine almost at the same instance for the sake of my example here, and one user is querying and the other one is updating his information. So in order for Sally to know the most expensive and the least expensive type of bread that Joe is making, she was going to write those two queries on the prompt. Let's assume that Sally is actually a database programmer, or at least she knows how to write SQL statements. So she goes select max price from cells where bakery equal to Joe's Bakery, and then she press enter. And then she goes later on select min price from cells where bakery equal to Joe's Bakery. Okay, so she's going to type those statements one after the other, and we're going to call them the max and min statements. Now Joe is going to go and type two different statements. He would like to delete first what he has been doing before, what he was selling before, so he typed delete from cells where bakery equal to Joe's Bakery, and then he insert the new type of bread using an insert statement. So what do we know about the order of things here, the interleaving of statements? We know that she's going to write max and then she's going to write min, the two sequences we were looking at. And we know he's going to write delete first and then he's going to write insert. But we know nothing else. We will make no other assumption. Since these statements are written one at a time, these SQL statements, according to what we know up to now, when each one of those statements arrive to the database engine, it will be put in a separate transaction. So we will have 4 transactions, T1, T2, T3, T4 running, because those developers, or basically Sally and Joe, didn't know about the transaction stuff that we have been discussing and don't know about what we're actually going to discuss in this part of the lecture soon. That's what they know. They know that they can write SQL statements, so they just went and wrote SQL statements according to the way things are run inside the database engine. Every one of those statements will be put inside a separate transaction. Every one of them will run in its own thread. So suppose, since we have no control on the 4 transactions and the 4 threads specifically inside the database engine, suppose this is the order of running things in the database engine. For one reason or another, the operating system decides to allocate the CPU to the max transaction. That's her first SQL statement. So the data then was 2.5 and 3 for the Shami and the Baladi bread. So the max of the two is 3. So she sees $3. And suppose a context switch happens and the delete transaction runs, which deletes the two entries. And then a context switch happens which runs the insert statement. As we mentioned, everyone is in its own thread, in its own transaction. So he does the insert. And then finally, a context switch happens, since the previous three terminated because there was nothing else to be done in the transaction. A context switch happens to the last one, which is min, and she runs her min query, or the database engine runs her min query. Obviously, I'm assuming here that they have sent these 4 statements to the database engine almost at the same time, or at the same instance. So when she queries the min, he inserted French for $3.50. Now she gets the min as 3.5, and she just saw the max as 3. So obviously this doesn't make sense. Now, where is the problem? The problem is that she is running her transaction, and also he's running his transaction, or his statements, and she's running her statements, not in a transaction. She's running them individually, one by one. And every single SQL statement sent separately to the database engine will be put inside a transaction running in its own thread. And then we have a situation that arises like the one we're looking at here. We have no control on who runs first, or which transaction runs and which transaction is not going to run first. Now, if we group Sally's statements, max and min, into one transaction, then she's not going to see this inconsistency. Okay? She will see Joe's price at some fixed point. Okay? Before Joe changes the price, or after Joe changes the price. Okay? Now, in the middle, while Joe is changing the price, she will see all data. Okay? Now, how can we get any one of those situations? What should we do actually to enable any one of those situations? Now, to understand how can we fix things, what we need to learn are the isolation levels that you can specify for a transaction. So the SQL standard specifies that a database engine should expose to the programmer who is using the database engine 4 isolation levels, and consequently give the programmer the flexibility to choose between them or associate or specify a specific isolation level for every transaction he creates. And these are the isolation levels. Unsurprisingly, serializable, that we have talked about, repeatable read committed, and read uncommitted. How do you actually specify an isolation level? You use the SQL statement set transaction isolation level, and you write the name of one of the 4 that are listed below. You can specify this statement in many database engines as the first statement inside the transaction body between the begin and commit, or if you have an ability to name the transaction when you create it, when you write the code for it, you can name it somehow, like you'd say begin and then you specify a transaction name. You can actually have a modified version of this statement where you say set transaction and you specify the name of the transaction, say buying items, and then you write isolation level and you specify the isolation level. So let's try to understand what each one of those means. In the serializable isolation level, well, it's called serializable for a reason, because this is actually is the way to guarantee to run your transactions inside the scheduler or by the scheduler in a serializable mode, which means you are asking the scheduler to generate a conflict equivalent schedule that is basically equivalent to one of the serial possible schedules that you can run the transactions in. Let me repeat that. This statement is not by accident called serializable or this mode or this isolation level. This is what we have been discussing in the previous part of the lecture. This notion of creating serializable schedules, specifically conflict serializable schedules. If you would like your transactions to run in conflict serializable schedules, then you specify the isolation level to be serializable. Now, serializable means it's equivalent to one of the serial schedules. Okay? So if you specify for Sally's transaction to run in serializable, this means either she runs before Joe or after Joe. So either she becomes T2 and T1 is Joe, or she becomes T1 and T2 is Joe. Yani either T1 followed by T2 or T2 followed by T1. If Sally is T1, then either she runs at the beginnings and it's T1 followed by T2, or T2 first, which is Joe, and then T1. That's the effect of using the isolation level serializable, and this is what I try to show at the bottom of this slide. You see that if she actually runs first, she is going to query the old data, so she will get the price for the Shami and Baladi 3 and 2.5. And then he runs. If he runs first, deleting the two types of bread and inserting the French 3.5, then she runs next, getting 3.5 and 3.5 because he only has one type of bread now. So running things serializable is obviously the best mode in terms of data consistency. But notice I'm associating the word serializable here, this isolation level, with Sally. So I am talking about her view of the world, her view of the database engine. If I say that Sally is serializable, Sally's transaction is serializable, that means from her perspective, she either is going to get the output of T1 followed by T2 or T2 followed by T1, from her perspective, not from his perspective. Okay? Because we associate isolation levels with every transaction, not with all the transaction. If I would like also to make him serializable, I would go to his transaction and type set isolation level serializable. So this is done per transaction, and it's done like this for a reason, to give you flexibility, as you will discover. And this is again to stress the point that serializable affects only how you see the database. I mean by you is the person who decides to run his transaction as serializable. Okay? Now, if Joe runs serializable, just to stress the point, if Joe runs serializable, so from his perspective, what does that mean? It means he will run as either before or after her. But if you look down there, she's not running before or after him. She's running in the middle, because we didn't say that her transaction is serializable. We said his transaction is serializable. Okay? Now, since she's doing a read, because her statements are all selects, she can run in the middle. Okay? Let me read this. If Joe runs serializable, but Sally does not, then Sally might see no prices for Joe's Bakery, because the following scenario that you see down there, highlighted as the last two statements, are possible for her. Okay? Now, because she didn't say that she would like to run serializable. Now, Joe's transactions run as if it's serial, because she is only reading, she is not modifying the data. Okay? Now, I know this will require a bit of thinking from your part, because we're not setting a global isolation level to all the transactions, but actually we are setting it per transaction. So the question becomes, if you set it to this specific transaction, what does this mean for this specific transaction? Okay, not for everyone else. Now, since she didn't specify an isolation level, her isolation level is not serializable. Obviously, unless the default, if you don't specify an isolation level, the default in the database engine is to make every past transaction serialized to run it in serializable isolation mode. But if this is not the default behavior, then it's most likely running it in one of the other 3 isolation modes. Now, just to complete the picture, you get a sense of what's going on here. We have another isolation level, which is called read committed. And by the way, they are listed from being, most consistent to least consistent in terms of the impact on the database engine. And you will see why. I will mention some examples why we would need the less consistent ones. Now, if Sally runs in read committed mode, if she runs her transaction in the isolation level that's called read committed, she will only see committed data. And remember, we reach the commit at the end of the transaction. So if he's doing modifications to the data and he didn't commit yet, Sally is not going to see his modifications because he didn't commit yet. Okay? So if you look at the example at the bottom, interleaving max, del, insert, and min is allowed. Why? Because when actually we run it in repeat committed mode, what's going to happen is that as long as he does not commit, she's not seeing his changes. So when she runs the max, she is actually querying the 2 types of bread, which is for 3 and 2.5. She queries the max, so she gets 3. Now, if he runs in the middle and he commits, she's going to see his committed data. So now the max and the min is the same, which is 3.5, so she sees the min as 3.5. Now we have a name for this type of output, because if she runs this same transaction or these 2 queries again, max and min, she is going to see 3.5 and 3.5 the next time, because the 3 disappeared because his changes were committed. And for this reason, we call this type of error, we have a name for it, it's called the non-repeatable read error, which means if you try to read it again, you won't find the information, it's gone. But you were reading it because at the time you were reading it, he didn't finish, he didn't commit yet, so you read the old data. Now, again, to summarize, a non-repeatable read error occurs when the transaction reads the same tuple twice and a separate transaction altered the tuple data in the interim. It's non-repeatable. If the transaction runs again, you won't see this error. You won't see the number that was produced as the max in the previous slide. Now we have a third isolation level. It's called repeatable read. Now, if you run a transaction in a repeatable read mode, what this means is that if you start with a piece of data or some data items at the beginning of the transaction, you will still have them all the way till the end of the transaction, even though some other transaction ran and deleted part of the data you're working with. Okay? Now let me repeat that. Repeatable read means you are going to read the same data that you have available at the beginning of the transaction. They are available for you all the way till the end of the transaction. So let's say there were 3 numbers, 1, 2, and 3. You start the transaction with 1, 2, and 3. Or say 3 rows, first row, second row, third row. If while actually you are running the transaction, since you started with these 3 rows, if while you're running the transaction, another transaction deletes row number 2, it will not be deleted from your perspective. The data will still be there. You still all the way have 1, 2, and 3, or the first, second, and third row, all the way till the last statement of your transaction, since you specify that you would like to run a transaction in a repeatable read isolation level. Okay? Now, if someone inserts, you will see the new rows while you're actually running the transaction, but the old rows will never be deleted. Okay? So this is an example of what I'm referring to. If Sally runs in repeatable read mode, when she starts, she has 3 and 2.5, the two types of bread. Now, if a context switch happens and he runs from beginning to end, he will delete and delete the two types of bread, the old two types, and insert the new one. So now the actual database has only 3.5. Okay? But what Sally is seeing in terms of the data, she is seeing the two old ones, the Shami and the Baladi, and the French as well. So when she goes and queries the minimum, she will get 2.5. Because it's as if what's going on here is that when you specify that the isolation level is a repeatable read, the database engine makes a copy of the data that you're going to work on and enable you to work on the copy. And in the same time, it's monitoring changes to the pages where it got the copy from. If anyone inserts a row that you should also see, it will insert it in your copy. So you will see the old data and also the new data. Okay? And this is the repeatable read isolation level. And obviously it has some advantage because at least the answer now makes sense. It's not up to date. It's actually, you can think of this as an old consistent state. But at least you're getting a meaningful answer because the data that you're working on has not been suddenly removed because of some other transaction that is also running at the same time. Now, the least strict way of running things is to run a transaction in the read uncommitted mode. Now, in the read uncommitted mode, you read anything even being modified by transactions that haven't finished yet, haven't committed yet. Okay? So obviously, this means this could result in data inconsistency if you're reading uncommitted data and those transactions that are running might not actually finish. They might face an error while executing for any reason, or they might just decide to cancel the transaction, which is possible. There is a statement in the SQL language called rollback. You just start a transaction and make a number of changes, and then if you decide you would like to undo those changes, it's like when you do undo in when you're typing in WinWord or in Excel, you can or in Eclipse, you can just do an undo. We have the same thing in SQL. There is a statement called rollback, so you undo the changes that you were making. Now, this other transaction that's running in read uncommitted will not know that the data has been rolled back, that the changes have been rolled back and the data has changed to the old copy. So now it's working with garbage data. It will continue on and do the processing and maybe even insert some computed value based on these garbage values into the database engine. So it might result in inconsistency. And this is an example of what I'm referring to. If we run Sally's transaction in the read uncommitted isolation level, when she runs the max, she's going to run the max query on 3 and 2.5. So she gets the maximum 3. Now, if context switch happens and he starts running, delete and insert, he will delete the two types of bread, he will insert the French for 3.5, and the context switch happens. Now, she's going to run the min, and there's only 3.5, so she gets back the min as 3.5. And now later on, let's say he changes his mind. So while typing in the same kind of transaction, he just types rollback. So rollback will take back the changes he made. It will remove the French for 3.5 and insert the Shami and Baladi for 3 and 2.5. But she ran her min before the rollback, so she's going to see 3.5. Okay? Now, this data is called dirty data because this was never part of any consistent state in the database engine. because his commit is reached after the rollback. I'm assuming here that he typed delete from whatever, insert whatever, and then the third statement is transaction, and his transaction is called rollback, and then the commit comes. So now she is reading garbage because this data is not part of any consistent state. Okay? And obviously if you try to read it again after he rolls back, it's as if it was never there, because really it was never there. Okay, so just to stress the point, dirty reads is when a transaction reads a record that is accessed by another transaction that isn't completed yet, that has not reached its commit yet. So to summarize, a SQL transaction can be run in one of four modes listed now here, from the least consistent to the from the most consistent to the least consistent: serializable, repeatable read, read committed, or read uncommitted. And this is the reference for today, this part of the lecture. Now I would like just to conclude this lecture by discussing why would anyone in his brain decides to use anything but serializable. Why don't we just go and every transaction we pass, just make it all of them serializable? Well, this takes us back to something we discussed early on, which is the use of locks. To enforce serializable schedules, database engines use two-phase locking. Two-phase locking is expensive. It's an expensive resource allocated by the operating system, and you need to use it wisely. So you have to consider your SQL statements and understand the nature of those SQL statements. What are you doing in them? And then think about the isolation level. Sometimes you don't need serializable at all. For example, I'll give you an example where it makes sense. Why would I ever need to use an isolation level like read uncommitted? If I am building a database for an engineering application that has thousands of sensors measuring temperature and humidity, and every sensor, say, is sending me one reading per second. So even if I have 1,000 sensors, just 1,000 sensors, I'm going to get 1,000 readings per second. Every reading is sent to me through some IoT network, using TCP/IP. I get this invocation of a method I have or a function I have that says insert this humidity reading and this temperature reading from this specific sensor number. Okay. Now, all the statements are going to be inserts, and they're all going into the same table, and every one of them is going to go and insert a new row in the table. So while I'm doing these inserts, I don't expect to be writing selects to query, say, the average temperature. I will do that every once in a while using another SQL statement that's basically goes select average, count, whatever, something like this. So why would I specify an isolation level of serializable? Because that means every time I run one of these thousand statements of inserts, because I have 1,000 sensors, then I am creating locks. So I would just avoid using locks at all by running it in a very relaxed mode or a very relaxed isolation level, and just run all of them as read uncommitted, and there will be no issue. Okay. Now, when I'm actually generating the report for the average temperature per a specific day, I might decide to write a transaction that runs in a serializable mode. But actually I won't. I will tell you why. Let's imagine, if we continue on with this example, that I'm going to generate the average temperature I'm going to generate a report for the average temperature in the last 60 days. So how many data points will be there? Well, in 60 days multiplied by 24 hours multiplied by 60 minutes multiplied by 60 seconds, that's really a huge number. Now, while I'm actually running the SQL statement that will generate or compute the average temperature and average humidity in the last 60 days, there will be readings coming from the sensors. There will be actually thousands of readings coming from the sensors. So let's think about this. If I'm having 300,000 points, say, that I'm going to calculate their average. And while I'm running this SQL statement that calculates the average, I get the insertion of 1,000 new points. So I will actually not run in serializable mode, I will run in read uncommitted mode. So what's the worst thing that could happen? Well, I have 300,000 numbers, I'm going to calculate their average, and I just added to them 1,000 numbers, and let's say I would be so unlucky that I would read 1,000 garbage values. Will it impact my average calculation? And obviously the answer is no. Because if you take the average of 300,000 numbers and you add to them 1,000 garbage numbers, your average is just going to be a little bit different, but not much different. So if the average temperature is 22, it's going to be like 22.2. Because you have another 300,000 numbers that you compute the average for. Okay? So basically the message is, if you can get away from using locks, then don't use serializable. Because you don't need all this extra overhead on the database engine. You only use it when you really need it. Like, for example, when you're doing business transactions and you want to make sure that you are not, for example, selling items from the stock while you are actually out of stock. If people suddenly start buying an item, like these days people are crazy buying Clorox. So, you don't want to, and you can get like 50 requests in a single second for Clorox bottles, and you're out of stock. So you will suddenly find that you have charged 50 people for money for an item you don't have even a single unit from. So yeah, and then you must use serializable, okay? Because you would like to revoke all these transactions and basically say, I'm out of stock, the stock is zero. Because you could have you could start by 60 bottles in your stock, and suddenly you have this 110 requests coming at the same instance for people buying this type of product. The first ticket that will run, will get the bottles, your stock, and the rest should be told we are out of stock. So you really need to run it serializable to make sure that you're guaranteeing or you're locking access to the resource to make sure that when you read it, no one else is modifying it, and consequently you're reading a consistent state in the database engine. But otherwise, stay away from serializable. And this also brings another issue. When you now think of any application you write, you got to go and inspect your SQL statements and understand, number one, what is the default isolation level by your database engine, because some of them will run your transaction always in serializable isolation level, which means you are overloading the database engine, and even with very moderate traffic, you will find that your database engine is getting slower and slower. It's because of the locks. And the second thing is, you have to understand the impact of running inserts and selects at the same time, because this is really usually the problem that makes you think of using locks. So if you can get away from that, it is actually better that you do the inserts, say in after hours or while people are asleep, and do the selects throughout the day, if that is actually possible. Sometimes it's not.